I am Venkata Rao, Professor of Mechanical Engineering, IARE, Hyderabad. Now, I will discuss about the topic sequencing model. So, in this, I want to discuss about the introduction, classification, assumptions, procedure, and example. The selection of appropriate order in which the customers may be served is called sequencing. The main purpose of sequencing is to minimize the idle time of the jobs, to maximize the profit or minimize the production cost. The effective utilization of machines will be reduce the production costs and increase the profit. Sequencing provide best procedure for optimum loading facilities. So, if the sequence is not proper, then the waiting time of the jobs will be increased. When the waiting time is increased means what will happen? The idle time of the mechanics, idle time of the machines will be increased. Then overall increasing the production cost. When the production cost increases, then we have to pay, we have to get less profit. So our intention is to select a best sequence so that the total cost will be reduced so that the total profit will be maximum. Then classification. The sequencing model is classified into two groups. First, N jobs M machines and 2 jobs M machines. In the first group, there are N jobs are there and M machines are there. The processing time corresponding to each job on each machine is known, and the order in which the machines to be used is also known. That means suppose we want to make an object. First we have to do the turning operation. Then for that we have to go for the example lathe machine. Then we have to make a hole in that object. Then we have to go for the drilling operation. Like that. What are the various operations to be done will be known. And how much time required for each job on each machine is also known. Then we have to sequence the jobs. Why we have to sequence? To reduce the waiting time of the jobs and waiting time of the machines. So whenever the waiting time of the jobs as well as the waiting time of the machines and mechanics are reduced, then our production cost will be less. Then the total profit will increase. In that case, suppose if the processes are known and the order is known and how much time is required is known, then what is the problem? We have to make a sequence. So we can make different types of sequences. Many sequences will be there. So in that we have to select the best sequence. Why we want to go for the best sequence? To reduce the idle time of the jobs. Suppose N jobs are there, factorial N sequences may be there. It is very difficult to test the each sequence and we have to find out the best sequence. In each sequence, how much is the time we should know. So in each case, we have to select. For that, this sequencing is very much useful. Okay. Then main assumptions in this. No machine can process more than one operation at a time. No machine can process more than one operation at a time. That means even though we can do more operations on a particular machine, but we should not do it. Only one operation should be done on that machine. So in the lathe machine is there, in that we can do turning and then drilling and knurling, various types of operations we can do. But only the thing is we have to use that machine only particular operation. Each operation once started must be performed till completion. Each operation, suppose if you started the turning operation for one particular job, you should not stop and remove that job and we can use the another job like that. We should not use the another job until the operation on that machine is completed. Then only we can go for the second job. We should not disconnect the first job in between. Then time required to transfer the jobs is negligible. So we want to transfer the jobs. Suppose one machine is here, another machine is there. Then we have to transfer this job to that. Even our assumption here is to transfer the jobs from one machine to another machine is negligible. So then a job, next assumption is there is one machine corresponding to the each type. So we are having one machine corresponding to each. Suppose lathe machine is one machine, milling machine is another machine, drilling another machine, shaping machine is next one. Like that, we are having different types of machine. But the condition is there must be only one machine corresponding to each type. Then a job is processed as soon as subject to the operating conditions or requirement conditions. That means whenever the time comes, we have to do that operation. The next, all jobs are known and ready to start when the consideration begins. So suppose first machine is completed, then it has to go for the second machine. In that case, the operator of that second machine should not say, I don't know how to do it. He has to do it immediately. So that means all the technicians should know the process, and whenever the time comes, they should operate it on the machines. Okay. Then procedure. So here we can find out the sequence, procedure for the finding out the sequence. Select the least processing time occurring in the list. So corresponding to the each job, timings will be given. In that we have to see for which job the time is minimum. So, and also we should know the order of the machine. Suppose two machines are there, A and B, and the machine should be used A first and B second. We should not use B first and A second like that. So first we should know the processing time, and second we should know the order. Suppose if the least processing time is on for job 1 and the order is AB, then we have to do the first job on machine A. First job on the machine A. Suppose if the least processing time is on machine B, that should be done at the end. We have to repeat the same procedure until all the jobs are sequenced. Now consider this problem. There are 8 jobs. Each job must go through the two machines M1 and M2 in the order M1, M2. Processing times are given below. Determine a sequence for 8 jobs so that we'll minimize the total elapsed time. Elapsed time is total time required to complete all the jobs. Find idle time for each machine and total elapsed time. Now, corresponding to the job 1, so 8 jobs are there, 1, 2, 3, 4, 5, 6, 7, 8, and machine 1. For job 1 requires 4 hours on machine M1, 5 hours on job 2 requires 5 hours on machine 1. Job 3 requires 8 hours on machine 1. Job 4 requires 10 hours on machine 1. Job 5 requires 6 hours on machine 1. Job 6 requires 5 hours on machine 1. Job 7 requires 10 hours on machine 1. And job 8 requires 6 hours on machine 1. Job 1 requires 8 hours on machine 2, 10 hours. Job 2 requires 10 hours on machine M2. Job 3 requires 2 hours on machine M2. Job 4 requires 4 hours on machine M2. Fifth job requires 5 hours on machine M2. Sixth job requires 7 hours on machine M2. And the seventh job requires 6 hours on the machine M2. And the eighth job requires 6 hours on machine M2. Now, first find the least processing time occurring in the list. So, first 8 jobs are there. First make a block consists of 8 slots. 1, 2, 3, 4, 5, 6, 7, 8. Now we have to find out the least processing time occurring in the list. So the timings are 4, 5, 8, 10, 6, 5, 10, 6. 8, 10, 2, 4, 5, 7, 6, 6. These are the timings. The least processing time is 2. That is corresponding to the third job on machine 2. So if the least processing time is on machine 2, that job should be done at the end. That means we have to write that one 1, 2, 3, 4, 5, 6, 7, 8. So we must write the J3 here. Why? The least processing time is 2 and that can be done at the end. So once it is completed, so you can remove this job. Then next least processing time, either 4 for job 1 or 4 for job 4 on machine 2. Any one. If there is a tie, we can select any one of it. Let us say we are selecting this one. First job we are considering, the least processing time is 4 hours on machine 1. Now that should be done first. So J1 should be selected first. If the order is order is 1, 2, then we have to consider the first job first. Then next lowest is 4. Now consider fourth job. This is corresponding to the machine 2. If it is a machine 2, that should be selected at the end. So that means job 4 should be considered from last to second. Then next least processing time is 5. So that is corresponding to the machine 1. So second job on machine 1. The least processing time is 5 hours. If it is the first machine, we have to consider from the first onwards. So that this is J2. J2 should be considered here. Then coming to the next lowest is 5 again. This is 5 here. So least processing time is 5, but the machine is second. Second means we have to come in from the last. So that this is J5. J5 should be considered here. Then when this is over, the next is again 5 is there. So again 5 is there. You can consider that one. That is corresponding to the job 6 and machine 1. Now you can consider J6 here. Then coming to the 6 again. Next one is 6. There are 3 6 are there. This can be considered. This can be considered. So that you can consider this one. 8th job. 8th job should be considered corresponding to the machine M1. So that you can take it as J8. Then this is over. Then so this job is also over. Next lowest is 6. This is corresponding to the machine 2. So it should be coming from the last, that is J7. So like that we have to find out the sequence. So first we have to select the least processing time occurring in the list. If it is the first machine, that should enter first. If it is the second machine, it should enter at the end. After finding out the sequence, find out the total time required for complete all the jobs. The sequence is J2, J6, J1, J2, J6, J8, J7, J5, J4, J3. Now, the first job enters the machine 1 at the time 0 and completed after 4 hours. So, processing of job 1 is completed on the machine 1 after 4 hours. Then it goes to the machine 2. So machine 2, then the time required for J1 on job 2 is 8 hours. J1 corresponding to this is 8 hours. So 4 plus 8 is 12. So job 1 is completed and the machine 2 at 12th hour. Now the second job enters to the machine 1 at after 4 hours. After 4 hours it will enter. That means it has to wait for 4 hours. The time required for job J2 is 5. Job J2 is 5 hours, and it will be finished by 9 hours. So after 9 hours, J2 will be completed on machine 1. Then it goes to the machine 2. So it has to wait until 12 hours because the the processing is not completed for job 1 on machine 2. Job 2 is not completed. So after 12th hour, the second job goes to the machine 2, and the processing time required is 10 hours, so it becomes 22. So now job 6 will enter the machine 1 after 9 hours and completed within 14 hours because the processing time is 5 hours, so it will be finished by 14 hours. Then it goes to the machine 2. At what time it will go? It will go after 22 hours only because the second job is still processing on machine 2. So after 22 hours, job 6 will goes to the second machine and completed in 29 hours because the time required is 7 hours. Okay. Then job 8 enters the first machine at 14 hour and completed after 20 hours. After 20 hours, and the processing time required is 6 hours. Now it goes to the machine 2. When at what time it will go? It will go after 29 hours. That means it has to wait for 9 hours because the processing is not completed for job 6 on machine 2. Then after 29 hours, job 8 goes to the machine 2 and completed after 35 hours. So because the processing time required is 6 hours. Now job 7 goes to the machine 1 after 20 hours and completed after 30 hours. Completed after 30 hours. The processing time is 10 hours. So it has to wait for 5 hours because job 8 is still going on machine 2. So after 35 hours, machine 7, job 7 goes to the machine 2 and completed after 41 hours because the processing time required is 6 hours. Then J5 goes to the machine J5 goes to the machine 1 after 30 hours and completed processing on machine 1 after 36 hours. At 41 hour, it goes to the machine B and the processing is completed on machine B after 5 hours, that is after 46 hours, the job 5 is completed on machine 2. Then job 4 goes to the machine 1 after 36 hours and completed after 46 hours and it goes to the machine 2 straight away by 46 hours because machine 2 is idle at that time, so that it will be finished by 50 hours because the processing time is 4 hours. 46 plus 4 is 50 hours. Then third job goes to the machine 1 after 46 hours and processing is completed in 54 hours because the processing time is 8 hours. Then goes to the second machine at 54 hour and the processing time is 2 hours, so the job will be completed after 56 hours. Now all the jobs are completed in 56 hours. The total time is 56 hours. Idle time for machine 1 is 56 minus processing time is 54 hours, so that the waiting time or idle time is 2 hours. Machine 2 is concerned, the processing time is 48 hours, the total time is 56 hours, so waiting time is 8 hours. So this is the idle times for the machines 1 and 2. Now we will consider the 5 jobs. There are 5 jobs, each of must go through the 2 machines A and B in the order AB. Processing times are given below. Determine a sequence for 5 jobs so that the total time will be minimized. Total elapsed time. Find the idle time for each machine and the total elapsed time. So first find out the least processing time occurring in the list. So 5 jobs are there. Make 5 slots. Then least processing time. So least processing time is in the first machine 4, 5, 10, 12, 15. In the second machine 3, 8. So the least processing time is 3. Job is J3. So you write the J3 in that block and consider this. Then the next lowest is 4. So you consider the 4 that is corresponding to the machine A and write J2 first. Then the next lowest is 8. So 8 is the next lowest. So consider this fifth job corresponding to the fourth place, because from the last we have to consider. Then this is over. Then coming to the next lowest is 12. So that you can write J1 and the next one is J4. So this is the sequence. Now the sequence is J2, J1, J4, J5, J3. So idle time of machine M1 you can calculate next. So the sequence is J2, J1, J4, J5, J3. So 4 hours are required, so that it will coming out after 4 hours. So then it will goes to the second machine. The time required for this is 5 hours, so that it will coming out after 9. So the first job enters at 4th hour and it requires 12 hours. That means it comes out after 12 hours, means 16th hour it comes out. Then the second job goes, the first job goes to the second machine at 16th hour. Even though the second job is completed at the end of the 9th hour, it is not possible to enter. So it has to wait, so that 16th hour it will enter and the processing time required is 12. So it will be completed at the end of the 38th hour. Then job 4. Job 4 enters at 16th hour and processing time required is 31. So that it will completed in at the end of 31. So that next the fourth job goes to the second machine at 38th hour. Why? Because still processing. Even though the fourth job on machine 1 is completed at the end of the 31, but still it has to wait until 38th hour. So the processing time requires are 6 hours, so that it will be completed at the end of the 54. So now J5. So at the end of the 31, the fifth job enters the first machine and processing time required is 41. So processing time is 10. So it will be completed in 41 hour. Next, the fifth job goes to the second machine at 54, because still the fourth job is processing on the first machine. Then 54 it will enter, but processing time required is 8 hours. 54 plus 8 is 62 hours. So that it will be completed. Fifth job is completed at the end of the 62 hours. Then J3. J3 will enters at 41, because J5 is completed at the end of the 41. J3 is enters at 41. And then the time required is only 5 hours on machine 1, so that it will be finished by 46th hour. Then the fifth job has to wait until the 62 hour, because still fifth job is going on machine 2. So that this third job enters the machine 2 at 62 hours and the time required is 3 hours. So the total time required is 65 hours. So now idle time of machine 1 is 65 minus 19. 65 minus 46 is 19 hours, and machine 2 65 minus 54 is 11 hours. The total time required is 65 hours. Now processing n jobs through 3 machines. So when the jobs are n jobs but machines are 3 machines, when 3 machines are there, then that can be converted into 2 machines type. How to convert that one? If this condition is satisfied, that means A minimum should be greater than or equal to B maximum, or C minimum should be greater than or equal to B maximum. either this or this condition is satisfied, then we can convert the 3 machines job into 2 machines type. So we can find out the timings for the 2 fictitious machines G and H. Corresponding to the G, the timings are A plus B, and corresponding to the machine H is B plus C. So in case of M machines are there, in case of n machines are there, in that case the timings corresponding to the machine G is A1 plus A2 plus up to An minus 1. Corresponding to the second machine, we will get A2 plus A3 plus M minus 1. We can write this one is M, this is M minus 1. So in case of M machines, this is A1 plus A2 plus to M minus 1. Gi is equal to A2 plus A3 M. Now consider these 3 jobs. There are 6 jobs. Each job must go through machines A, B and C in the order ABC. Processing times are given below. Determine a sequence for 6 jobs so that it will minimize the total elapsed time. Find the idle time for each machine and total elapsed time. The corresponding machine A, job 1 is required 8 hours on machine A, 7 hours on machine B and 13 hours on machine C. Job 2 is concerned, it requires 6 hours on machine A, 4 hours on machine B and 12 hours on machine C. Job 3 requires 10 hours on machine A, 6 hours on machine B and 11 hours on machine C. And fourth job requires 7 hours on machine A, 5 hours on machine B and 12 hours on machine C. And fifth job requires 9 hours on machine A, 5 hours on machine B and 13 hours on machine C. Then sixth job requires 7 hours on machine A and 4 hours on machine B and 10 hours on machine C. Now you see the timings. What is the A minimum? A minimum is 6 hours. B maximum is 7 hours. The first condition is not satisfied. The second condition, C minimum is 10 hours. So C minimum is greater than B maximum. So either A minimum should be greater than or equal to B maximum, or C minimum should be greater than or equal to B maximum. So the second condition is satisfied. So we can convert the 3 machines type into 2 machines type. Now the timings corresponding to this one. So for the machine M1, let us say fictitious machine M1 and M2. Corresponding to the machine M1, the timings are, we have to add the first two. 8 plus 7 is 15. 6 plus 4 is 10. 10 plus 6 is 16. 7 plus 5, 12. 9 plus 5, 14. 7 plus 4, 11. Then the second machine is concerned, 7 plus 13, 20. 4 plus 12, 6. 6 plus 11, 17. 5 plus 12, 17. 5 plus 13, 18, 4 plus 10 is 14. So like that we can find out the timings. Then sequence we have to find out. So the sequence can be obtained. So again draw the block corresponding to the number of jobs. So 1, 2, 3, 4, 5, 6. Now consider least processing time occurring in the list. So the least processing time corresponding to the machine 1 is 10. So you have to take the machine 1 first. So that is job 2. Corresponding to the job 2, we have to select the job 2 first because this is the least processing time. The next processing time is 11. So 11 corresponding to the sixth job on machine 1 only. So now you can select J6. Next, least processing time is 12. That is corresponding to the job 4 corresponding to the machine 1. So that you can take this one as J4. Next least processing time is 14. So corresponding to the job 5. So enter job 5 here. Then the next processing time is 15. So you can enter the first job after 5. So that is J1. Next processing time is 16. that is corresponding to the third job, that should be entered at the last. So this is the sequence. J2, J6, J4, J5, J1, J3. J1, J3 is the sequence. Now write the table for finding out the idle time and the total time required to complete the jobs. So here the sequence is J2, J6, J4, J5, J1, J3. Then machine A, the second job enters machine A at 0 time and completed after 6 hours. It is completed after 6 hours. So then the second job enters to the machine B after 6 hours and the processing time required is 4 hours, so that it comes out after 10. So then the second job goes to the machine C after 10 hours and the processing time required is 12, so that 10 plus 12 is 22. Then coming to the J6 enters to the machine A after 6 hours and the time required is 7, so that it will be completed after 13 hours. So that this second J6 job enters the second machine, that is machine B, after 13 hours because the J2 is completed after 10 hours. So that we can send the J6 to the machine B. The time required is 4 hours, so that it will be finished by 17th hour. So then the J6 should go to the machine C after 22 hours. Even though it is completed at the end of the 17 hours, it should wait because still the processing of job 2 is going on machine C. Then so it will enter the machine C at 22 hour and the processing time required is 10, so that it will be finished by 32 hours. Then J4 enters the machine A at 13th hour and processing time required is 7 hours, so that it will be completed by 20th hour. Then machine B, it enters to the machine B after 20 hours because it has to wait. It need not wait because it is already vacant, so that it will goes to the machine B at 20. Then the processing time required is 5. So 25 it will be completed. Then it has to wait up to 32 because still J6 is processing on machine C. So it has to wait up to 32 and it will be finished by 44th hour. Then J5 should enter at the 20th hour and processing time required is 9 and it will be finished by 29. So it will goes to the machine B at 29th hour and processing time required is 5 hours and it completed within 34 hours. So after 34 hours straight away the fifth job cannot go to the machine C because still processing is going on, so that it has to wait up to the 44. At the 44 hour it enters and the time required is 13, so that it will be finished by 57. Then first job enters the machine A at 29 and the processing time required is 8 hours, so it will be finished by 37. And first job goes to the second machine at the end of the 37th hour and time required is 7 hours, so it will be finished by 44 hours. So the job 1 goes to the machine C at 57th hour because processing is going on machine C corresponding to the job 5. So it enters into the machine C at 57 and the time required is 13, so it will be finished by 17th hour. 70 hours. It will be completed after 70 hours. Then J3 is concerned. It will enter to the machine A at 37th hour and processing time required is 10 hours, so it will be finished by 47 on machine A. Then machine B goes to J3 goes to the machine B after 47th hour, and processing time required is 6 hours. So the total time required is 53. So total time required is 6. So it will be finished by 53rd hour. 53. At the end of the 53 hours, it will be completed. Then the J3 job goes to the machine C at 70, because it cannot go to the machine C after completing the process on machine B, because still J1 is processing on machine C. So it will enter the machine C at 17th hour, 70 hours. After 70 hours, it will be goes to the machine C, and the processing time required is 11. So it will be finished by 11 hours. So that means at the end of 81 hours, all jobs will be completed. And idle time for machine A is concerned. So total time required minus processing time of that machine A. 47 hours are required on machine A. So the waiting time of the machine A is 34 hours. So the waiting time of the machine B is 50 hours, because the processing time of machine B is only 31 hours. Then machine C waiting time is 10 hours. The processing time of machine C is 71 hours. So this is the solution. The total elapsed time to complete all the jobs is 81 hours, and idle time for machine A is 34, machine B is 30, and machine C is 10 hours.
Like, share and subscribe. Hit the bell icon for more updates.